So the first question is only about identifying the strongest acid based upon inductive effect. Always recall this: more minus I, more acidic strength. Next, among the following groups, in which of the following is the order of minus I effect? Minus I effect is something we need to mug up. We can't help anything about that. So NO2, SO3H, then F, then NH2. This is what we have seen. So which means this would be first, third, second, and fourth. It will be second one. Consider the following carbanions, right? You have to check out their characteristic in terms of stability. Always remember that negative charge more stable on more electronegative atom. Positive charge less stable on more electronegative atom. Electronegativity can be find out on the basis of what is the bonding it has. This carbon has sp3, this has sp2, this is sp carbon. Higher the s character, more is the electronegativity. So third one will have more electronegativity. So this can handle negative charge better than this one, than this one. So 3, 2, 1. That should be the order. Okay, guys. Which of the following species contains 6 pi conjugated electrons? You just have to find out how many number of conjugated electrons are present. You can see that resonance will always take from the lone pairs. Lone pair will support as a double bond. This double bond can move. This double bond can move. So the number of pi bonds here are 3 pi bonds, which means we have 6 electrons, 6 pi electrons which are delocalized. This is anyway aromatic ring. You can see that this is tropylium carbocation. This has also 3 pi bonds, and all of them are delocalized. Here 1, 2, 3, all these 3. This lone pair is not being in the plane of pyridine. So because if you see the structure wise, this is how the pyridine looks like. Pyridine would have orbitals this way, and these orbitals are actually making pi bonds here, here, and here. And the lone pair present on it, here is perpendicular to that of pi orbitals. So therefore, this lone pair is not going to participate in resonance. So only these 3 are participating in resonance, which shows that this also has 3 pi bonds. Hence all of this. Which of the following is most acidic in character? You have to only check out the inductive effects or withdrawing nature. See, here NO2 has minus I effect as well as minus M effect, which means it is strongly electron withdrawing group. CH3 will give you plus I effect as well as hyperconjugation. So it is very good electron donating group. Bromine is giving minus I plus M, but for halides minus I is more dominant, so it is electron withdrawing group. So these two are electron withdrawing groups, and always remember that more electron withdrawing group, more is the acidic nature, and more electron donating group, less is the acidic nature. So which is most acidic here? B. If you are asked the order, then B, D, A, C. Okay. Which of the following compounds are more acidic than water? I gave you the complete list of family of compounds. 15.7, formic acid 4.13, benzoic acid 4.3, phenols 10, and this is acetic acid, which is normally between 4 to 5. So here it may be approximately around 4. Got it? So you were asked which of the compounds are more acidic than water. You can see the one which has the lower pK value, that will be more acidic. So 1, 2, 3, 4, all of them. So all of them are more acidic than water. Have you all understood this? Next, which of the following carb anions are more stable than this one? So you need to check out here. There is strongly donating groups. More plus I effect, less is the stability of carb anion. Carb anion stability will be less, which means this has highly unstable form. This is an highly unstable form. Now here you can see fluorine is withdrawing. Any minus effect will increase the stability of this. So this is more stable. In CCl3, we have resonance also. CCl3, all chlorines are withdrawing group, as well as the minus charge will undergo back bonding. So here also this is more stable. Secondary is more stable than tertiary, and NO2 is strongly withdrawing, so that is also more stable than given carb anion. Okay, so I guess you understood how to check that question. Next, uh, which of the following compounds lone pair does not participate in resonance? Okay, we just learned that pyridine's lone pair does not participate in resonance. Here lone pair is, adjacent to a double bond, so this will definitely make a resonance here. Here lone pair want to do, but unfortunately this is an sp3 carbon, so it can't do it. Here lone pair can easily make resonance. Aniline will always have this resonance form, so answer should be A and C. I hope you guys have done that. Polarization of electron in acrolein by resonance. See, always remember this whenever you have C double bond O and then there is an adjacent double bond here. Okay, whatever the bond lines are, this pi bond will never shift here. Reason, if that shifts there, oxygen will get positive charge and it will become octet incomplete. And oxygen would never want to be octet incomplete because it is highly electronegative in nature. So this side resonance is never possible. But the counter side is always possible, which means this double bond moving here, oxygen moving here. So resonating structure would be CH2 plus CH double bond C, O minus and H. This is possible. So in this, if you see that this oxygen is gaining negative charge, carbon is gaining positive charge. Any of those structures will be possible. The one which we cannot write, you can see this carbon is never getting a positive charge. Correct? This carbon will never get a positive charge. Only the terminal carbon will get positive charge and oxygen will get negative charge. Right? And same is this carbon also. This carbon is not going to get any positive or negative charge. So therefore, first one is incorrect. Okay. Second one is also incorrect. Third one is the only correct structure. Fourth one is also incorrect structure. Clear on that? Next, in which of the following molecules all atoms are in coplanarity? Always check out the hybridizations, that will help. 1, 2, 3, 4. All of them being sp2, which means everything is planar. So all atoms are planar here. Okay. Here this is sp3, sp3 to sp2 character, but here this is completely sp3. So it is definitely non-planar. Here, although this may be planar, the hydrogens present here, one hydrogen will be going inside, one hydrogen will be coming outside. Here also, one hydrogen going inside and one hydrogen coming outside. The other carbons may be planar, all other carbons may be planar. Here the question is about all the atoms. So since they are sp3, in this case they are both are sp3 carbons, so all atoms cannot be planar, so this is also non-planar. Lastly, here you can see sp, these two are sp2 and these two are sp, which means all of them are planar. So the question asked is, which of the following are all not coplanar? So B and C does not have any coplanarity. Identify electron donating group. Resonance, in resonance C. NO2 is strongly minus I and minus M group, and this is electron withdrawing group. NH, it is electron donating group, so it has minus I and plus M, and plus M is dominant, so which makes it electron donating group. CHO minus I as well as minus M, minus I minus M, overall it is electron withdrawing group. NH2 is electron donating group, minus I, and its plus M is much stronger, so electron donating group. So these two are electron donating, A and C are electron withdrawing. Which of the following pairs of structures do not represent resonating structures? If you see double bond O, OH, problem here is hydrogen. This hydrogen has been completely replaced here. In resonance, hydrogen should never be replaced, or in fact, any atom should not be replaced from its mean position. Here, you can see this lone pair will try to make a triple bond and complete the octet of carbon, which means these two are resonating structures. Here, lone pair on nitrogen can extend the conjugation here, moving this pi bond. So we will get this canonical, so which means these two are resonating structures of each other. Here the same problem, hydrogen has been completely shifted onto oxygen. Atom should not be shifted, that is not resonance. Okay. In which of the following molecule resonance effect of the group is not observed? See, here octet is already completed, so nitrogen cannot accept any more electrons. Sulfur can accept electrons because it has an empty d orbital. Empty d orbital. Oxygen can extend the conjugation here and making a resonance to happen. Ammonia cannot accept the electron because its octet is completed. Octet completed. So A and D are those cases where octet is complete. Sorry. Which of the following are resonating structures of the phenol? Phenol, you can see the lone pair on oxygen will donate electrons. This pi will shift here. So the first canonical you will form is this one with double bond OH plus. Next canonical, this pi bond shifting here and the pi bond coming at para position, OH plus. Again lone pair shifting here, pi bond shifting on this position. So we'll get minus double bond, double bond, double bond OH plus. This shifting here, this pi shifting above. So we would get this as double bond, double bond, double bond with OH. These are the 5 canonical structures of phenol. Now you see that this one and this one is exactly same. So this is definitely a structure of phenol. Second, this para and this para, this is same. So this is also structure of phenol. This one and this one is also same. So this is also correct. Last one, positive charge never comes here. So this is not the structure of phenol. So ABC. Which of the following carbocation is more stable from this one? We can see that this is coming from an sp3 hybridized carbon. This is coming from an sp hybridized carbon. Here, this is sp3 with electron withdrawing group. Fluorine is electron withdrawing by nature. Here this is coming from sp3, and there are strong supporting of plus I groups, and here also we have plus I groups here. It is also coming from sp3 and it has strong support of plus I groups. So you can see that this is more stable, this is more stable, because 1 methyl support is 3 methyl support is more stable than 2 methyl compared to that of 1 methyl group. On the contrary, B and A, either the hybridization is less, which means it is highly unstable with positive charge, and withdrawing group will only make it even more less stable. Right?
Sir, so answer should be CD, right?
Which of the carbocation is more stable? C and D beta.
Sir, they have given ACD. I also mark CD.
No, only CD. Okay.
Okay,
Tell
sir.
them to change it if they have given it. Okay.
Okay, sir.
How many carbocations are stabilized by resonance? See, there is a resonance that is happening here. Here there is no resonance. Both sides there are no pi bonds. Okay. So this is one case. Next, this pi bond can shift here, so resonance is taking place. This pi bond can shift here, resonance is happening. Here there is no resonance, only inductive effect. Here we have only plus I effect and hyperconjugation. Here resonance will happen. Here resonance will happen. Here again only plus I and hyperconjugation. No resonance effect. Here resonance can take place. So we have total of 6 structures where resonance is taking place.
Sir, again I got 6 wrong.
Check beta 6 only. I think I got the key which also has
Same,
6.
sir.
This is correct. You guys can just claim it. Okay. Don't worry.
Okay, sir.
How many following carb anions is more stable than this one? This is secondary. Anything which is primary will always be more stable than this. So this is more stable. This is also more stable because there are withdrawing groups. This is also withdrawing, so more stable. This is less stable because there are more methyl groups which is supporting. This is also highly unstable. Here there is withdrawing group, so this is also more stable. Here, if you compare this CH3 and this C2H5, C2H5 is more donating. So even this is less stable. Okay. So 1, 2, 3, 4. So total number of carb anions here which are more stable are 4. Okay. How many of the following compounds are acidic from this molecule? Here we have isopropyl group connected to COOH. So there are two methyl groups which are trying to support that COH, so which means it is decreasing the acidic character. So there are no CH3 groups, this will be more acidic. There is only one CH3 more acidic. There is a withdrawing group that makes it even more acidic. There are three methyl groups, it is less acidic. There are three, this is same as methyl groups only, this is also less acidic. There is a withdrawing group here, more acidic. Withdrawing group here, more acidic. So how many do we have? 5 compounds showing more acidic strength. How many resonating structure for troponium carbocation? Total in troponium, pi bond will shift on all the positions of carbon. So total 7. Okay, this is how it is. If you shift this positive charge from here, I'm writing from the first structure. This is how it is. Shift the pi bond. So we would get carbocation here. Double bond this way. Shift this pi bond here again. So we will get positive charge here. Double bond, double bond, double bond. Again, shift the positive charge. So we'll get positive charge here. Double bond, double bond, double bond. Shift the positive charge here. So again, you'll get positive here. Double bond, double bond, double bond. Shift the positive charge here. So we'll get positive. Double bond, double bond, double bond. Shift the positive charge. We'll get positive charge here. Double bond, double bond, double bond. shift the positive charge again, we'll get positive charge back here. So these two are same structures. So take it as one. Then, so we have 1, 2, 3, 4, 5, 6, 7. So total how many? 7 canonical. This I think they have given the key wrong. Make sure you claim for this if you have done it 7. Okay.
सर चेंज हो गया था.
Now, find out the number of ion having delocalized charge. So here it is delocalized from both the sides. This is also delocalized. This cannot be delocalized because it is an sp3 carbon, so no resonance. This can be delocalized. This positive charge cannot be delocalized because this positive charge which is present is on a carbon where the pi bond is different. These are the pi bonds which they have, and you can see resonance is happening this way, and somewhere here there is a orbital which has positive charge, and that orbital is perpendicular to this pi bond, so there is no involvement of this pi orbital, so there is no resonance. This plus charge is not delocalized, this minus charge is delocalized. Here this cannot delocalize anywhere because there is no pi bond present adjacent to it. Even this want to delocalize, this is an sp2 carbon, sp3 carbon, no delocalization can take place. So how many places here you can see? 1, 2, 3, 4. So in 4 places we have delocalized charge. Okay, right. So these are the cases you must be careful with. If you have anything to learn, please let me know. Any other doubt in it?